Will we start, ma'am?
Yes, sir. Principal, sir, Vice Principal, sir, we are going to start, sir.
Yeah, okay, madam, no problem. Please start.
Yeah.
Good morning, one and all present here. I, Dr. Gunavati HS, Associate Dean, Skill Development, Assistant Professor in the Department of Computer Science and Engineering. I welcome all of you for the 3 days webinar on National Mathematics Day 2022. On the occasion of birth anniversary of Indian mathematical genius Srinivasa Ramanujam, he is born on 22nd December 1887. On this occasion, the National Mathematics Day has been celebrated. To celebrate this mathematical day, so we are organizing this webinar. The main motto of the webinar is to provide the platform for the students and the faculties to know about the recent trends and advances in mathematical applications in engineering. So in the today's presentation, we have two expert talks. So tomorrow it will be a presentation from the students, a PPT presentation on the mathematical applications. The day 3 is a project exhibition from the students. So the schedule will be like this, and all these details are already been shared with all of you. And now I request our Dean, Dr. Rupa Madam, to welcome the gathering. Over to you, ma'am.
Thank you, Gunavati. Good morning, everyone. I have great pleasure and honor to welcome you all for the 3-day webinar on National Mathematics Day 2022, being organized by Skill Development Center in association with Karnataka State Council for Science and Technology, Department of Science and Technology, Government of Karnataka. I am Dr. K. M. Rupa, Dean for Skill Development Center and also Student Welfare Officer at Bangalore Institute of Technology, a premier engineering institute in Bangalore, Karnataka. I take this opportunity to our respected principal, BIT, Dr. Ashwath MU, sir, for this webinar. In absentia, I'm welcoming our beloved principal, who has been the guiding light and constant source of encouragement for organizing this webinar. I also welcome our esteemed Vice Principal, Dr. J. Prakash. He has been a constant inspiration for organizing this webinar. Welcome you, sir. This webinar is organized with the financial support of Karnataka Council for Science and Technology, Department of Science and Technology, Government of Karnataka. I wish to express my hearty welcome to Sri Hemant Kumar, Executive Secretary, and also Sri Venkatesh, Program Coordinator, KSCST, in absentia, for their support and encouragement. I also welcome all deans, heads of the department, PG coordinator, associate and assistant deans, our colleagues, faculty members and students from various colleges who are attending this webinar. Thank you.
Thank you, ma'am.
Okay.
Welcome to you, ma'am. I request our beloved Vice Principal, sir, to address the gathering. Over to you, sir.
Thank you, Madam Rupa and Madam Gunavati. At the outset, I congratulate the Skill Development Department of BIT is initiated and conducting a program on National Mathematics Day. And definitely, it's a very good program. It enlightens the role of mathematics or the applications of mathematics in engineering. Srinivasa Ramanujam, everybody knows, is the genius in mathematical field. Even today, we are going to remember his contributions in mathematics with respect to mathematical analysis, number theory, infinite series, continued fractions, in many fields of mathematics. Even the government of India in 2012, the Prime Minister was the Manmohan Singh. He was declared December 22nd is the National Mathematics Day to remember the contributions of Sri Srinivasa Ramanujam in the field of mathematics. Even in 2012, Indian stamp featured Srinivasa Ramanujam also. On 26th December 2011 at Madras University, Sri Manmohan Singh was declared December 22nd, we have to celebrate as National Mathematics Day. Since then, India is celebrating this particular event every year with numerous educational events held at various schools and universities throughout the country. In 2017, actually, the day significance was enhanced by the opening the Ramanujam Mathematical Park in Kuppam, Andhra Pradesh, in the event of, or in remembering the event of National Mathematics Day. Today, to remember this event, under the umbrella of Skill Development Center of BIT, the Dean, Dr. K.M. Rupa, and Associate Dean, Dr. Gunavati, arranged a very good program, association with Karnataka State Council for Science and Technology, to celebrate this National Mathematics Day by arranging a 3-day webinar on advanced mathematics or applications of mathematics in engineering. Congratulations, madam. And also, I wish a good luck to all the participants to get benefit from this particular event. Thank you very much, madam.
Thank you, sir. Thank you very much.
Thank you very much, sir, for your enlightening our audience about the speciality of today. With this, I request my fellow colleague, Dr. Maya BS, to give the introduction about the speaker. Yes, ma'am.
1 minute. 1 minute. 1 minute. Still is not yet joined. You please wait
Okay.
just 1 or 2 minutes.
Yeah,
Okay.
we'll just wait till the speaker join the session.
Yeah, sir is going to join within 1 or 2 minutes. I'm requesting everyone, don't quit the meeting. You please wait another 1 or 2 minutes. Sir is going to join because we are closing early for our inauguration. That's why you please be cooperate. Thank you. Good morning, sir. Yeah. Gunavati, please make the sir is host, presenter.
Yes, ma'am.
Gunavati? Yeah.
Yes, ma'am.
And then Maya, you please introduce after once sir is become a presenter. Please introduce sir.
Okay, ma'am.
Sir, very good morning, sir. Sir, your voice is not audible, sir. Sir, voice is not audible.
Yeah. Now it is audible?
Yes,
Yes,
sir. Yes, sir.
Okay.
Good morning, sir.
Very good morning.
Yeah.
Sir, I've given the presenter permission for you, sir. So you can just check once whether the slides can be shared.
Just a minute. I'm trying to open that one. Give me a couple of minutes.
Yes, sir.
Sorry for getting delay. So something is wrong here going on. Okay. Can I share with you?
Yes, sir.
Okay. Share. Is it okay?
Yes, sir.
Is
Your
it visible?
screen is visible, sir. Actually, the slides are not visible. Yeah, now it is visible.
Okay.
It's working, sir. I request my fellow colleague, Dr. Maya B.S., to introduce today's speaker.
Thank you, Gunavati
Over
ma'am.
to you.
Thank you. Is audible?
Yes, Maya.
Yeah, it is audible. Please go.
Good morning. Good morning, sir. Good morning to one and all. See, myself, Dr. Maya B.S., Assistant Professor, Department of Computer Science. It's my pleasure to honor introduce the today resource person, Dr. Ratikanta Behera. So, thank you, sir, for accepting our invitation for today's session. So, sir is currently working as Assistant Professor in the Department of Computational and Data Science, Indian Institute of Science, Bangalore, India. And sir is have a research experience of his completed his PhD degree in mathematics 2013, Indian Institute of Technology, Delhi. And he has also received postdoctoral researcher December 2013 to 2014, University of Notre Dame, USA, and postdoctoral research in January 2015 to July 2019 of Laboratory and Jean Kunzman, Joseph Fourier University of France. And also I received one more postdoctoral research into December 2019 to May 2022, Department of Mathematics, University of Central Florida, USA. Apart from this, sir has published more than 30 papers in the reputed journal he published, and he is also a reviewer in International Journal of IEEE Transaction and Signal Processing, Linear and Multilinear Algebra, Applied Mathematics and Computation, Bulletin of Iranian Mathematical Society, Journal of Applied Mathematics and Computing, Journal of Computational and Applied Mathematics, Advances in Applied Xylophone Algebras, American Mathematical Society Mathematical Review, Acta Applicanda Mathematica, International Journal of Modern Physics, Spatial Matrices, Numerical Functional Analysis and Optimization. And also, sir received 4 research grants for the project title Tensor Valued Wavelet Analysis and Application to Solution of Differential Equation for the February 2018 to the December 2019 for the funding agency for this Science and Engineering Research Board, Government of India. The second project title is a dynamically adaptive wavelet algorithm for solution of evaluation equation with localized structure for the June 2018 to December 2019. The funding agency, Science and Engineering Research Board, Government of India. And third one, the project title, Efficient Algorithm for Solving Tensor Structure Equation and Their Applications. The June 2022 to June 2024, that funding agency is IIC Bangalore. And we have one more, designing algorithm for tensor decomposition and inversion to solve multilinear system, that approved for December 2022 for the coming 3 years. And funding agencies, Science and Engineering Research Board, Government of India. And also, sir, have mainly concentrate on that the laboratory development for the numerical algorithm and tensor learning. So it's mainly concentrate on this laboratory. The laboratory it's available in that part of the Department of Computational Data Science in IISc, and lab are developing for adaptive recurrent neural network to solve time-varying sensor equations. And the goal of this lab is design innovative, scalable, efficient sensor-based algorithm supported by theoretical principle to solve significant existing and emerging multidimensional problems, and is also supporting for that coming for the studies for high performance tensor contraction in scientific computing, tensor generalized inversion application, tensor decomposition and approximation, high performance algorithms and implementation of tensor operations, optimization of algorithm for the tensor computation, adaptive space-time wavelet algorithm for PDE, design adaptive space-time current and its applications, dynamic adaptive algorithm for image encryption, tensor methods in applied computational domains. So mainly concentrate on tensor operations with applications to the machine and deep learning with mathematical knowledge. And sir has experience of the teaching with the different universities, IISc Bangalore, University of Central Florida of USA, IISER Kolkata, India. And with all this, I warmly welcome to the today's session, sir. Thank you, sir. Thank you very much for accepting our invitation, and over to you, sir.
Thank you. Thank you very much for the brief introduction about me as well as about my research. So let us start with the talk. So I'm going to share with you my screen once again. Okay. So I think it is visible now.
Yes, sir.
Okay. So the title of the talk basically tensor computation in data science. So data science is a very broad sense. You can say like let's say someone saying that I am doing engineering. So there is no meaning that engineering if that guy is not saying that specific direction, like engineering in computer engineering or like a mechanical engineering, other things. Same thing in data science, you can specialize in different way. So somebody said that I'm doing AI, means artificial intelligence and neural network and machine learning, different direction. So people can say that we are working on that way. Then what is the role in tensor computation? So all our field, so we need some tensor computation. So what is tensor basically? So in this talk, we'll talk about introduction of tensor and what is the motivation for the tensor computation. And we'll talk about Einstein product as well as T product, how to multiply two tensor in this way. And then we'll talk about some application of tensors. So come to here. So what is tensor? Tensor is a type of data structure. So those people are based on like a mechanical engineering or physics background. They may think that tensor is stress tensor on something different way. So here I'm pointing out that tensor is a name. So this name, that kind of data structure, so used in machine learning to represent a various kind of object. So that you can say the scalar, vector, or array, matrix, and other tensors. Or some people also, they represent the tensor is a higher dimension generalization of matrix and vector. Or some people, they may say that it is a multi-dimensional array. Is my voice is audible properly?
Yes, sir.
Okay.
It's audible.
And the order of the tensor is defined by the number of directions required to describe it. So let us consider a number. That number is a scalar. Okay. So that there is no direction. So that is a tensor of order 0. And a row vector or column vector that you can represent in one direction. So that is order 1 tensor. And matrix you can represent I and J. So that is like two direction. If you say that two-dimensional array, so that we can say that tensor of order 2. Similarly, so this picture, so this is a tensor of order 3. And this is a picture that this one, so I'm pointing out, so that is the tensor of order 4. So how it is 4? So think about that, kind of each element is a third order tensor. So if each element is a third order tensor and we make it a column way, or we can make it row way, so that is a fourth order tensor, because one indices is saying that I, j, k, and another is that star. So this is a fourth order tensor. Similarly, if you make a picture in that way, like a matrix representation, and each element of the matrix is a third order tensor. So that is, this one is a fourth order tensor. So here, you may say that, okay, so this is a matrix, but that matrix, each element is a third order tensor. So this is kind of sixth order tensor. So this third order tensor 3, and again it is, fifth order tensor. Third order tensor, again, this is row and column. So this is fifth order tensor. And the last figure, so that is a tensor, each element is also tensor. So if you think that is, this is a 3 indexes I, j, k, and each element is also I, j, k. So if you write it I1, I2, I3, again also I1, I2, I3. That means this is a sixth order tensor. So what and why we use this tensor? So mathematical modeling of problems in science and engineering typically involves solving multilinear system. So that multilinear system, standard matrix representation data analysis is not enough to represent all this information contained in higher dimensional data field. For example, I'm giving you, suppose you and your friend is going one school, collecting the date of birth of all these school children. So then, suppose that is a one classroom and only 5 students is there. So that means either you can say that row wise or column wise, you can store it. If it is like in that class, there are 50 students is there. So 50 students, definitely they will see the row and a column. So you can say that 5 row, 10 column. So that is a tensor of order 2. Suppose you like to get this information. This information means collecting the date of birth of all children in that school. So that school, let us consider this is a class 1 to class 5. So now we are getting a matrix information of one class. One class means suppose class 1. So 50 student and that 5 row, 10 column. So you get this information. Okay. So suppose the 5 classes, that means you need 5 different matrices. So instead of 5 different matrices, I can say that you can store all this information in a third order tensor. That one slice is considered kind of class 1, and then class 2, and then class 3, and class 4, class 5. Okay, suppose there are 5 different schools in that field, is that place is available. So how you store? So you have to store as a traditional way, like a matrix representation of way. So you can store like one matrices, let's say school number X, class number 1, that is you store it. Then school number Y, class number 1, and you store this information. In this way, you can store, let's say 10 school, 5 different classes, and each classes is 50 students. So then it is kind of difficult to write it in matrix representation. So this one way we can say that tensor is a multi-way array. That is a natural representation for massive multidimensional data. This is one example. Another example, let us see a stadium. So suppose you are going a stadium and some person is sitting somewhere. You don't know where it is sitting. So how to find it? So you will go to see that which section is sitting. And then once you identify the section, then you have to find out row, and then you have to find out column, and then find that seat. So this is kind of 3D or three-dimensional tensor. And then if you see that finance data, so that is, let's say, finance institute like bank, which year, which month, which day. So this is kind of fourth order tensor. You have to write it in one tensor, all this information. However, in matrix representation, you need 4 or 5 matrices, specifically if you go to 1 to 4. If you like n number of institutions and year, that means let's say 100 years information and 12 months, 30 days. You just imagine how the matrix, different matrix you require. However, in tensor, you just need one tensor to store all this information. And also another field like geographical data. So in geographical data, let's say you are in Bangalore, someone is sitting in Delhi, someone sitting in Mumbai. So, and you have to collect some information about the temperature, rainfall, pressure, and specific which time. And that is also belongs to latitude and longitude. So let's say you collecting all this information. You just imagine how different kind of matrix required to store all this information. But in tensor, you can write a tensor A to collect the information. So then people say that why only the collection of information is tensor required or something else? So that is also another story. Let's say you are collecting the information. When you need, let's say, addition of temperature or subtraction of temperature or some kind of operations you require, like matrix operation, then also you need tensor operation. And another field like data on health status, like you have to go to a hospital and do some kind of analysis like blood analysis, immune system, genetic background, nutrition, and alcohol and tobacco drug consumption, and number of operations. If you do this kind of things, so it's required different matrices. However, in the tensor, you store it one tensor, fixed all this information, and then on other tensor, you fix all the information. So this way, it will be easy for the operating on tensor. Multiplication, division, inverse, all these things. So tensor, that means what we conclude? That tensor is required all over every field. For example, neuroscience, multilinear algebra, video and image processing, computational geophysics, and the big data analysis, statistics, everywhere. Even if those are in software engineer, they are also required to develop that kind of library and programming language based on the tensor. You may have the name of TensorFlow or tensor processing unit. So all these things nowadays required because of the higher dimension of data nowadays we require. Again, let us give one specific example like color image. So color image, let's say one image is there. So image means there is some intensity of red, green, and blue. Because color is represent either red, green, blue, that intensity is represent 1 pixel. So suppose you have like a 256 by 256 size of a image. And that is, if it is color image, so that will represent 256 into 256 into 3. Why 3? Because red, green, and blue. That you can represent 3 matrices, like red matrices, green matrices, and blue matrices. So here what happened, let's say you need to discuss some kind of what you call operation. Let's say definitely I will discuss that one also. So suppose you take a picture, and that picture is some kind of blur is there, either your side or the image side. Like let's say you take a picture, at that time your hand is shake or something, so then picture a kind of blur is coming. Or suppose you take a picture, someone is running, so some kind of blur will also come. So how to get a blur-free image directly using tensor computation? So this is the kind of applications we can do it. And again, let's say, suppose a traffic signal, traffic light is red. However, one person is coming very fast and to cross that traffic. For the God say there is no other accident, nothing is there, but we have to punish that person. That means how to punish? That means get the what do you call information of this car or that vehicle number. But as very fast it is going, so the camera is not capturing perfectly. So mainly that number plate is not visible. So how to get it that correct number of this vehicle? So that is also required tensor computation. So you may say that we can do it in matrix. Yes, you can do it in matrix. However, it's required more computation time as well as more information. Why? Because each time when you do, so you have to break that image to red, green, and blue, 3 matrices, and then analyze it, and then go back to that tensor and then say that something is there. So tensor representation saying that we can do directly. So no need to do any ad hoc procedure to do it. Okay. Another is color video. So color video. So color video is basically, if you see a kind of image, so collection of image is a video. So if you in your mobile phone, let's say you collect 10 or 20 pictures, so that represented video. So each frame is a color image. That means this is a 4th order tensor. So one is like red, green, and blue, 3 direction, and another one is time direction, each frame. So let's say you are trying to see that 20 frame or 100 frame, that means 100, that is a 4th order color video. And again, also in video applications, I can say, suppose you see a video or you see a movie, so that movie 1 second is deleted or something is there. What happened in that part? So as for, I expect that people are know that numerical methods and interpolation, all these things. So then they can do interpolation on video to get it what is this happening in this specific, what you call moment or specific second. So that information we can get it. Another example, let's say relation data. Suppose a matrix collection of relations among multiple objects. Suppose the item is available like a cab, umbrella, light, or something, and the user, let's say 4-person user is there. So then this is kind of a matrix that you can collect this information. However, if you include another things is which time, so this user will use this item in a specific time. This user, second user can use a different time with the same items. So this kind of relation, it comes a tensor. So relation pair is matrix two-dimensional array. Relationship of a triple. So that is called third order tensor. Three-dimensional array, one for items, one for time, one for user. So this is basically tensor. So tensor representation is generally high dimensional and large scale. For example, suppose let's say three-dimensional tensor. Okay, so that is 100 user, 100 items, or 1000 user, 1000 items, and 1000 times. So that is how many relationships, if you just imagine, like 10 to the power 9, 3. Okay, so to develop tensor-based model or applications, we need efficient scalability and productive and reliability. Whereas if you do same thing in matrix, so you cannot get efficient computation way. So you see this, if you write it this as a matrix relationship, so it is so huge. Even if just 100 user, so think about like Facebook, how many people use one specific moment, like a crowd of user using one specific 1 second or 1 moment. So this time of you can do this way. So that is a very big matrix. So that's why nowadays tensor processing unit and tensor flow, tensor computation, all these things is much more popular. Okay, so let's how we represent. So this is kind of, I gave the example and motivation how tensor useful and where we'll use it. So let us consider only third order tensor because it will be easy for you understanding what is happening. A higher order analog of matrix row and columns are fibers. So like in matrix, what we are saying that row and column. So if it is 3D, 4D, we cannot say that row 1, row 2, row 3 or column 1, column 2, column 3 because row is represent one specific direction, column is represent specific another direction. So to make it generalize, so the representation of tensor, or first of all, think about the matrix. So column, we can say that mode 1 fiber, row is mode 2 fiber. So that easily we can extend it mode 1 fiber, mode 2 fiber, mode 3 fiber, and so on if it is n-dimensional tensor. Okay. For example, the third order tensor. So third order tensor. So think it like a matrix. So matrix is kind of one book. Okay. So one is column and one is row. So if it is third order, something is here. That means a vertical direction. So we can say that column, row, and tube. One specifically, you can say that one line, you can say column, one right line in this way that we can say that row, and one line in upper part that we can say that this is tube. And then if you write it kind of slice wise, so horizontal slice, vertical slice, and frontal slice. Let's say you are keeping your book, 5 book, you are keeping one by one. So that means this is kind of horizontal slice. You can take one piece of book at a time. And that book, you can keep it like vertical. So one slice or one book, you can keep it. And frontal slice, one pieces of this way. So this is the different representation of the tensor. So when you need a computation, we can use this terminology, or you can use this technical word like slices, horizontal slice, vertical slice, and frontal slices. Then let us, what kind of research we can do. So this is the basic idea that what is happening and what like tensor, where you use all these things. So the basic things is multiplication. So you know that two matrix, let's say A is a matrix of size m by n, B is a matrix of size n by p, and C is a matrix that you can multiply A into P.
This is your y1 and the point of BA by 3A by 3. But you have to find y2 using this formula, not this one. Y1 means the way you get it. Find y2.
Any doubt? Hello?
How to find y2?
Differentiating y1.
Again, you have to use the 2 by b formula. So y2 is
Abhishek
equal to
Mallikarjun sir.
what is 2 by b?
Any doubt
Abhishek
or
Mallikarjun sir, please unmute, please mute. Abhishek Mallikarjun sir.
So using that, first DR means
Gunavati, please mute him.
so this will be what is
Abhishek
Ma'am.
Mallikarjun.
I'm trying to check where it is. Yes.
okay. Now
Okay.
Okay.
Yeah, done, sir.
Sorry, sir.
Okay, no problem. I thought that some doubts they are discussing each other. So, okay, it's fine. So, focus on research. What kind of research we can do in this tensor computation, or kind of this tensor flow or tensor in machine learning or data analysis. So, first of all, you understand that multiplication point of view. So, two matrix we can multiply like A into B. So that represents C, and C of ij we can write A of ik, B of ij. Make it a tensor because each element of a tensor represent like I1 to IP, or like third order tensor we can say that I1, I2, I3. So then suppose a pth order tensor, that order is P, so that we can represent I1, I2, IP. B is the same kind of tensor. Then how you multiply? So multiplication is a big challenge. And here, if P is even, so we can say that this is even order tensor, and P is order, then we can say that the specific tensor A is odd order tensor. So forget about the P, like N1, N2, and P. Suppose P equal to 3 only. So like A is a tensor of size 3 cross 2 cross 3. I'm giving you a simple tensor. And the B is a tensor of size 2 into 3 into 3. Then how we multiply? We know that matrix multiplication, but tensor multiplication, we don't know still now. Tensor multiplication, different people, they use in different way. For example, there is very traditional way Einstein discussed the Einstein product. And recently it's discussed like a T product. Using tensor product, shortly we mentioned T product. So using that one, we can do it. So what theoretical point of view we can do it? We can say that multiplication of two tensor, that we'll discuss in this slide also. And decomposition of tensor. So what is decomposition? So let's say a number, suppose a number is 12. So 12 divided by 24. So how do basically, so what will be the answer? So usually 12 you can make a factor 2 into 3. And 24 you can do accordingly 2 into whatever that factor. So this way it is easy to cancel out 12 by 24 or 12 by 36, whatever that. Suppose a big number is there. So 12 by 24, obviously you can say that 1 by 2. But suppose a big number is there, 6-digit number divided by 10-digit number. So this way, you can say that I can do it in computer or I can use in calculator. But as a beginner, so what we'll do? We can make a factor. And then both factor, if same factor, you can cancel out. So this is the useful for easily operating the numbers, we need factors. Same thing like a matrix factorization. So most of students, I think they know that LU decomposition, eigenvalue decomposition, SOR decomposition, different kind of decomposition or factorization, they know. So why you know why and how we use that LU decomposition? So one is lower triangular matrix, one is upper triangular matrix. Okay. So when you solve a system AX equal to B, so in that way, so you can make your A matrix to LU so that it is easy to compute X. Instead of finding X equal to A inverse B, we can write it X equal to in term of L and U. However, this decomposition, we cannot guarantee that all matrix decomposition, all matrices have LU decomposition. There is some restriction. If it's positive definite, it's symmetric, kind of something, then we can say that we have to do based on that background or based on that conditions, we can say LU decomposition. Again, some people know also singular value decomposition. So same kind of story or same kind of analysis, we can do it tensor because we have huge data in different field. It's not about a particular field. I discuss with you different field that we have many data. So that data, it is difficult to handle it. So we have to do some kind of decomposition or some kind of factorization. So if you do that factorization, if you do that decomposition, then you can analyze. And again, if you do that one, again also we need inverse. So like a system of equation, AX equal to B, X equal to A inverse B. For example, suppose that inverse is exist and that is unique. So you can say that X equal to A inverse B. So do you think that is there any inverse is exist in tensor? That also required some kind of analysis and some kind of research. So anyhow, I will discuss one inverse here, one decomposition here, and one multiplication of here. Okay, and then application point of view. So as I already discussed with you that image deblurring, so kind of like a traffic story I discussed with you. So find the number plate of a vehicle if it is blur or some kind of not visible properly, so that you can detect. Again, compression, image compression. Suppose you have 100 picture or 100 photos and each photo is 10 MB or 20 MB because of the high resolution photo. And you like to send your friend or you like to store a device or mobile device or anywhere that is not fit with this huge or this high resolution pictures. So what you will do basically, you compress this image accordingly to your device storage. So you can compress and then you store. So you can say that if I compress, then that picture quality will be less. Yeah, definitely, that picture quality will be less. But if you need the picture, let's say some accident is there, so you need quality or at least one picture to prove it. So sometimes we compromise quality to get the picture. At least some picture is coming, then we can detect that one. And also same thing like face recognition. And those people are working on partial differential equation or ordinary differential equation. That is also useful in solving Poisson problem or other problems. So specifically, I will discuss here in Poisson problem. Okay, so this kind of applications also we can discuss. This kind of theoretical point of view we can discuss. So Einstein product. So maybe some people know what is Einstein product. However, I am making it general and giving this some drawback what is happening. So matrix multiplication that I already discussed, and you people also know because of this is 12th standard, maybe in school level also, it is, you have already read this one. So Einstein product is basically generalization of this matrix multiplication. Generalization in what sense? Let's say, suppose A is a tensor that what is the size of 2n, because I1 to In, again K1 to Kn. That means a even order tensor, okay? And a B is a tensor that K1 to Kn and J1 to Jm. So these two tensor, if you operate a Einstein product of nth component B, that we can write I1, I2, In and J1 to Jm. So think it like here, A of Ik, B of Kj. So I1 to N and K1 to Kn and B K1 to Kn and this one. So this way we can multiply. So what is the generalization? So generalization, if you think n equal to 1, this big one, big N, suppose n equal to 1. So then I1 and I2. So here A I1, I2, B of B2, J1. So this is the simple extension of our well-known matrix multiplication. Again, suppose A is this one and B is only K1 to Kn. Then also we can write A and B, and that is belongs to this set. That means product is belongs to this set. So here C is defined that complex number. A is a tensor and its element may be real number, may be complex number. For a broad sense, I'm writing that a tensor A and its element is either real or complex. That is work on this one. So this is the very old, you can say that the Einstein product, and these authors, they collect this paper and published in 1997. Okay. And then, so another way, what happened? That the common framework of tensor computation. So what usually people do, turn a tensor to a matrix. Suppose a big tensor is there. So you try to translate this tensor, because people don't know how to multiply the tensor, how to operate with the tensor. So then you translate or transform a tensor to a matrix. And through matrix computation, you know the matrix computation, that means you know matrix factorization, matrix inverse, and all these properties, you know matrix. So this matrix computation used to get the matrix A. That means what is happening in this matrix. And we draw a conclusion about the tensor based on what we learn on the matrix. Because our original tensor, we convert a matrix, and this matrix in the right hand side, that we know all these properties. So once you play with these properties or compute in this one, and then come back to the tensor. So this is the kind of story usually people do. However, it is not true for all tensor. So that we'll discuss. Let's say you define a tensor T. So that is I1, I2 and I1, I2. That means this is a fourth order tensor, and that is even order, and that direction is I1, I2 and again I1, I2. Okay. And that we can transform to a matrix. So what will be the size? So that size will be I1, I2 multiply here. So here in difference, so we can multiply. So maybe it is difficult for your understanding. So I'm giving one example. Suppose a matrix size is 2 cross 3. So that matrix, we can make it a column vector or we can make it a row vector. So 2 cross 3 matrix, if it will be a column vector, so that is 6 cross 1. That means that elements will not go anywhere. Element will be there, but we represent in a column vector, or we can represent is in a row vector. 2 cross 3, so we can write 6 cross 1 or 1 cross 6. In similar way, we can transform this tensor to a matrix. So that we can write f of a, if your transformation f of a equal to a, defined in this component wise. Okay, equation 4, where a is a tensor, this curly a, and this normal a is your matrix. So in general, make it a general way, like I1 to IN, again J1 to JN. So we can write that this tensor can represent a matrix and this index is represented this way. So now we are getting the idea that tensor we are converting as a matrix. You can say that this is always true, but this is not always true. In matrix, to column vector and row vector is easy. It is always you can write in this way. However, when you deal with the operations and coming back to this operation, we need some additional properties. So that if, let us consider, is defined in equation 4, then the following properties hold, means the map F is bijection. Moreover, there exists a bijective inverse map. That means we have to come back to matrix to tensor. And this matrix map is satisfy these properties. F of star 2, that means this is a second order tensor. That means 2 indices is multiplied. So f of a star 2 means 2 indexes is multiplying, and f of a into f of b. And this dot referring to the matrix multiplication. Why matrix multiplication? Because this is what you call f of a is a matrix, f of b is a matrix, and this f star 2, f a star 2b, this operation is tensor. So this is the idea of like matrix to tensor computation. So see, suppose a 4th order tensor. So that tensor, that is how we represent a element a of ij 1 1, ij 1 2, 1 3, 2 1, 2 2, 2 2. If you consider the tensor of size, this one. So this is a what you call 4th order tensor. So how it is 4th order? If you relate like my first picture, so that is kind of, this is a 2 cross 3, this is a matrix, and each matrix is a matrix. Sorry, each element is a matrix. So think it that this is a whole matrix and each element is this way. If you write this element, sorry, this tensor to a matrix, so this is a bigger matrix. So if you do some kind of operation, this what you call this big matrix, and then you go back and you can say that this is my tensor computation. Then your job is done. However, this is not true always. So if you see the drawback of Einstein product. So if you define the same transformation, so what I told you in equation 4, sorry, yeah, equation 4. So that is this way. So using the above definition of tensor A, I1, I2 and I1, I2, which can be extended only a square tensor. That means we can go I1, I2, IN, again I1, I2, IN, like a square matrix. In square matrix, row and column are same. So here Einstein product, we can see that this is kind of one row and this is kind of column. If both are same, then this operation is possible. Again, this extension of arbitrary order tensor is impossible, because F is not homomorphism for even order or arbitrary order tensor. So this is kind of homomorphism properties. Those are in mathematics background, they know that. So these properties will not satisfy. Again, the Einstein product is not defined for the following two even order tensor. So as for the point 1, I told you that it can be possible only square tensor or even order tensor. So square tensor is okay, but even order tensor is not okay. So even order tensor, that is A is I1, I2, J1, J2. Even order because 1, 2, 3, 4, 4 different way it is going even, and same thing is here. So multiplication is not possible, because if you consider this is a row and a column, and this is row and a column. So multiplication is possible if it is first matrix or first tensor. This part should same as this part. Okay. So more details, those are interested to do some kind of research or more interested, they can go over this. This is one of my paper that published in 2020. So we discuss many things about it. Okay.
Hello.
So, sorry, yeah, please go ahead.
Hello, sir.
Yeah.
In Einstein product, as we have seen, via the map F, we can go from tensor to matrix. And
Yes.
also, there is one property where what we are doing, that we can go from Einstein product to general matrix product, and we are coming back from matrix to tensor Einstein product. So
Yes.
in that case, we can do everything in matrices, like
Yes.
by changing the tensor to matrix. So what is the
Yes.
benefit to define this Einstein product in tensor?
Yeah, exactly that I'm saying. So this I'll talk next slide also. So here I'm giving you the brief answer of this question. Suppose you have a tensor that size is I1 to I100 or I1000. Okay, are you getting my point? So that means this is 100 order or 1000 order tensor that you represent a matrix.
Yes.
And each order, let's say m by n, and n is 50 and n is 50. So here m is, let's say I1 to In. So each one, let's say 100 into 100 into 100. So that you convert a matrix. So this is a very huge matrix. For simple example, I'm talking about fourth order. So that is okay. But if you make it a general, like 100 order tensor, and one direction is also 100. So you just imagine how bigger matrix you will get it. So that is the computational not suitable. One question, one answer. Other answer is that you can do this map as for I discussed with you. So this map, you can turn a tensor to matrix and do it. However, some kind of tensor, you cannot do it. Because here Einstein product this way, it is not possible. Only it is possible like even order and square. Did you get through this 3
But
points?
sir, I'm not getting your this second point. Sorry.
This one? The
Second
extension
point,
of
what you have said, just for square tensors.
second point means this point or this one?
No, what you have just said.
Okay, so I told you that if we can extend it only for square tensor. Okay, so however, if you say that if even order tensor, it is not possible because Einstein product is not defined. And one more example I'm giving you, that efficient solution of Poisson problem. So I hope you know that what is Poisson problem. This is kind of elliptic equation. Yes. So consider a d-dimensional Poisson problem, that is del square u equal to f. Consider a simplicity for Dirichlet boundary condition. That means on all the boundary is 0. So if you solve this problem using the matrix vector way, so what you need, so you have to solve a system Ax equal to B, where A is a matrix, that size is, if it is a second order, like a two-dimensional Poisson problem, so A should be n square cross n square. Okay, and the B is a vector like n square cross 1, and your solution X is n square cross 1. If it is a 3-dimension, so it is nq cross nq. And what is n? N is basically the internal points or interior grid points. So traditional matrix vector approach, it is impractical, because if you see, let's say n equal to, sorry, d equal to 3, just 3D, do it. And n equal to 100, suppose 100 interior points you are considering with Dirichlet boundary condition, then we obtain the matrix A is 10 to the power 6 into 10 to the power 6. You just imagine, we have to solve that problem X equal to B, and A is 10 to the power 6 into 10 to the power 6. So this is huge. Even if this D equal to 3 and only 100 number of interior points, if you do high resolution or like localized solution, suppose you get it, so you need a very dense grid or like high resolution, n maybe thousands or 10,000 or 100,000. So in that case, so this matrix will be huge. However, this problem we can do it in tensor representation way. So this maybe it's concrete answer what you asked me in last slide. So Ax equal to B, if you write it A equal to 10 to the power 6 instead of this matrix, we can represent this tensor A is 100 into 100, 100 into, that means 6 times. And X is instead of 10 to the power 6, so we can write it this way. So now we have a simple problem, multilinear system. Instead of a linear system, we have a multilinear system, Ax equal to B. So this easy way for solving the 3D Poisson problem. Even if you go for higher dimension, you can do it. Is it okay?
Yes, sir.
I understood. So let's go over more detail of the Poisson problem. So Poisson problem, if you consider the two-dimensional cases, so the two-dimensional Poisson problem, let us consider that xy is 0 to 1 with the boundary condition, with the Dirichlet boundary condition. Same thing, I just wrote it. So as you are in numerical background, let's say, so use 5 different 5-point pencil central difference scheme on the discretization on the unit square domain, because it's a 0 to 1 x and y is 0 to 1 with n interior nodes. We get the following system. So A is n cross n cross n x b. So what is the tensor A? So that tensor A, you can write it A equal to in Kronecker product of Pn plus Pn Kronecker product of In. So what is In? In is a identity tensor, or you can say that if it is a 2D problem, so this is a identity matrix. And the Pn is a second order tensor. Always think second order means it is a matrix, and third order means it is actual tensor. So Pn is a tridiagonal, that -1 to 1. So if you do it, so this is the 5-point tensile and this is a 7-point tensile. So suppose a 3D problem. So 3D problem, you use this one, okay, 7-point tensile. So for 3D Poisson problem with the same boundary condition, like a Dirichlet boundary condition, we obtain the tensor equation A star 3. That means, what is this? This Einstein product star 3 and B equal to this. And then the tensor A we can represent in this way. Suppose you can extend this one in the 4-dimension cases and as well as the higher dimension cases. Okay. So after that, we'll talk about the what you call T product. So T product, this is a kind of other way to multiply, and that will be better than the Einstein product. However, some restriction is there. So before you start T product, let's see what is circulant matrix and some background also required that I am going to discuss. Let's C belongs to Rn. Rn means C is a vector. That vector we can represent C1 to Cn. Okay. And then the circulant matrix we can write C1 to Cn. Again, that Cn will be in first element, and then this way we can write circulant circ of C. Similarly, if C1, C2, Cn are matrices, then the circulant of C1, C2, Cn, we can write it in this way. Now, the tensor A that I told you, like A is a pth order tensor, suppose I1, I2, IP. So if you hold the last index, that means AIP. So then it will be a one less order P. So that means for I1 to INP, AI equal to AI belongs to this size of the tensor, and that is the order of P minus 1. So what we get it? So here AI is created by holding the pth indexes A by fixing I. For example, let's say we have a fourth order tensor A. So that is 2 cross 2 cross 2 cross 3. So if you fix it last index, so what happens? So we'll get 3 third order tensor. So that means now fixing the fourth index of A, we get 2 cross 2 cross 2. That means third order tensor that we can represent A1, A2, A3. And that elements are this way. Okay. So here we can say that the third order tensor, so the meaning of that third order tensor is looks like a cube of data. By orientation of third order tensor is not unique. So if you see somebody, one side is green, blue, or red. So if you make it turn, so different color will come. Same thing, like someone represent, so in this way, A of I1, sorry, IJ1 and IJ2. Someone say that A of 1 IJ, 2 IJ. So why orientation is not unique? Because this elements is not same as this element. Are you getting my point? So IJ1 is not same as 1 IJ, not same as I1J. So that means orientation is not unique. So this is the way we can say. And then how we multiply. So as I told you, like a multiplication Einstein product, it is easy and it is a simple way we can multiply as a matrix kind of generalization version, you can multiply it. But T product is doing something different. So here we define the two different transform. One is unfold transform, one is fold transform. So what is unfold transform? So that tensor turn into a matrices. So suppose a tensor M cross P cross N, that you can turn like Mn cross P. Okay, and the fold is inverse operation. That matrix to tensor. Suppose you are giving this Mn cross P matrix, and it will return this tensor MnP tensor, such that fold into unfold of A equal to A. So think it that this is a tensor that we are keeping in frontal slice. First red, then purple, then yellow, and finally green. So that means if you do it last indices, that A1, A2, A3, An. So unfold is a transform, that tensor, this one, to make it is a column vector. And that column vector in the sense, in the column wise, and each element is a matrices A1, A2, A3, An. Why it is matrices? Because this is a third order tensor. If it is fourth order, something different. So this is another way, like this column, we can transform as a fold operation, get that one. So then the product of two tensor A into B, so that we can write AB equal to fold of sharp of unfold of A into unfold of B. So what is this meaning? For simplicity, let us consider two tensor. A is M by P by 3 and B is a P by Q by 3. Both are third order tensor. And the size is defined in this way. So fold operation is fold. Sharp of unfold of A. So unfold of A, basically A1 to AN, because here 3 is there. So we can say A1, A2, A3. So that circulant. So that means A1, A2, A3, again A3, A2, A1, A2 in this way. And B is unfold of B. So what is unfold of B? Basically A1, A2, AN. So here B, so B1, B2, BN. So how you multiply? So if you multiply, so A1 is a matrices and B1 is a matrix. So that now simple block matrix multiplication. So this is not our work basically. So this is originally like Martin discussed in Sham Journal of Scientific Computing. So this product. So last one I discussed with you, that is Einstein product, and this is T product developed by these authors Martin, Sheffel and Lehrer. So consider a fourth order tensor. In your mind that third order it is easy. Fourth order tensor, what will happen? So let's say A is a size of N1, N2, N3 into 3. And B is a tensor of N2, L, N3, 3. So why I wrote it 3? So because it will be easy for you to hold the last index to get it 3, A1, A2, A3 is a 3 third order tensor. Are you getting my point? So here sharp of unfold, this is kind of thing. Now if you multiply, so this A1, again A1 is a third order tensor, that we can write it sharp of this way. And otherwise, other elements we can write in this way, then we multiply. For more clarity, I can say this is a simple example of two tensor multiplication, A into B. Is it okay? I can go ahead another 10 minutes or I can stop it. Hello?
Continue, sir.
Okay. So suppose A and B, I'll finish it within 10 minutes. Maybe less than that. A and B, so two tensor. That size is, think about that interesting how it is like a matrix multiplication, you know, but tensor multiplication, it's kind of something different. So A is a size of 3 cross 3 cross 2 cross 2 and B is this one. So as for one student told me that we can write it as a convert this tensor to matrix and do multiplication and go back. But it is not always true that I told you. But here this we can do in this way like T product. So as the last indices is last one is 2, so we can write A1 and A2. And each A1 and A2 is a 3 cross 3 cross 2 tensor. So sharp of this, and B also same thing. If you write it, so this is a third order tensor, and all are basically third order tensor. So you can multiply like A1, B1, and plus A2, B2, kind of matrix multiplication, do it. But not as a matrix, because A1 is a third order tensor, B1 is a third order tensor. Again, we need another fold on fold operation. So think is like A1 star B1. So this is fold of A11, A12, A12, A11, because this A1 is a third order tensor that we convert is a matrix. So similarly, we do other. So now this guy. So that A11 is a matrix now. B11 is a matrix. So we can write in this way. Similarly, we can write other. So finally, if you see that A11 is a matrix, B11 is, sorry, yeah, B11 is a matrix. So all are matrix. So this way we can write the tensor product A and B eventually reduce a 3x3 matrix multiplication. So best we transform, this is tree product in the sense by step, by recursively, we can come back and reach a matrix multiplication and do it. So this is one decomposition that I told you, like tensor decomposition. And this is a powerful decomposition, like tensor singular value decomposition. So those are used to singular value decomposition of a matrix that you can do for any matrix. However, eigenvalue decomposition, LU decomposition, they need some kind of restriction. Singular value decomposition of a matrix, there is no restriction. That means any matrix you can do singular value decomposition. Same way, we can extend it here like a tensor singular value decomposition. I'm not going to the details of this theoretical part of tensor singular value decomposition. So use this tensor singular value decomposition, we can calculate or we can compute Moore-Penrose inverse. So Moore-Penrose inverse is a generalized inverse that we can do it. Those are more interested about this Moore-Penrose inverse singular value decomposition, they can go through my paper or our paper. So this is a numerical linear algebra and application. This is 2021 published. So now we'll see some applications, color image deblurring. So like first few slide I told you, let's say some blur image is there or blur number plate is there when you take a picture. So that how you can do blur free. So that we can write a image blurring problem, Ax equal to B. You have blur image. So think it that is a B. So B is a blur image. A is known. X you have to find out. So how to find out? Now X equal to A inverse B. Inverse means here Moore-Penrose inverse. The symbol saying that like in inverse we are saying that -1. So here Moore-Penrose means a dagger. So this symbol is, those are in mathematics background, they know that this is a dagger symbol or a Moore-Penrose inverse. That we can compute. So once you compute, this is the reconstruction image. If you see, it is clearly visible all the fruits. So here it is not visible which fruits is there. So this is kind of applications that we can do directly using tensor. And again, like I told you, like let's say you have many pictures, you have to store it with the help with a compromising of image quality. So suppose this is your true image, you have to store it. So that storing, maybe this one, which one you like, you can store it. So based on your requirement, if you see in WhatsApp, even if your mobile camera is high resolution 4K or ultra, but if you send this picture to your friend via WhatsApp, that quality will be less, because they do some kind of algorithm that is best for the sending. So that is the use of singular value decomposition. Okay, and those are interested, they can go over this following references. Basically, this is our research, most of, and those are in pioneer of the paper or developed paper that I cited on that page only, like in SAM Journal of Scientific Computing and Einstein product, and the rest of things they can follow here. So anything, any doubt or any questions, I would be happy to answer it.
Audience can unmute yourself and any queries you can ask with sir.
Hello.
Yeah. Hi.
So, sir, in the same way, in T product, we are also going to the ultimately matrix multiplication.
T product, yes.
So I just want to see, matlab, example where, yeah, you have given Poisson equation. Uh,
Yeah, you like to see this one?
no, I just want to know, I mean, when we are going to matrix multiplication in T product also, so in that product also, when our first two modes are very large, then also we will feel complexity in matrix multiplication, na, or some
Yeah,
problems.
yes, yes.
So this will also problematic in T product. Then
No.
there what we do.
So why no? Let's say. So just a minute. Is it visible?
Yes, sir.
Okay. So see, this is your tensor. Okay. So is 3 cross
Yes,
3,
sir.
2 cross 2. Okay. So fourth order tensor. If you do it a matrix, so what will be the size of the A? So A would be 9 cross 4. Yes or no?
4.
And B would be 9 cross 4. Yes?
Yes. Uh, yes.
3 into 3, 9, and 2 into 2, 4. So 9 cross 4 and 9
Or
cross 4.
either I can also choose na 992. 18 by 2, 18 by 2, something like that.
Yes, you can do 18 by 2 and then this one 18 by 2.
Yeah.
So if two matrix 18 by 2 and 18 by 2. So can you multiply?
Sir,
Can you
my question is that
can you multiply?
no, AB could directly, no, we cannot.
You cannot multiply. I understand your question. Let's go through this one. Sometime if you convert this matrix tensor to matrix, multiplication is not possible. Suppose multiplication is possible as per your query. Are you understand? Suppose A is all are 3 and B is all are 3. So that means there is no restriction on multiplication. Okay. However,
Yes.
only thing is that matrix size will be large. So if you convert it in this way, so this, what is the size of A11 into B11? So A11 is a 3 cross 3. If you see,
3 by
eventually
3.
reduce to 3 by 3. So you just imagine that, let's say 3, 3, all are 3. So 9 cross 9 matrix, it's converted to only 3 cross 3. And that partly we multiply it. So this way it is convenient, or what you call like easily multiply, and computational efficient will come. And other way, so like as for the P product structure, so that is converted to a circulant matrix. So there is a beautiful properties in circulant matrix using Fourier transform. First Fourier transform. So if you use first Fourier transform on a circulant matrix, it will give only diagonal element. No need to do this kind of computation. It is easy and straightforward way. You can use the first Fourier transform to get this multiplication. Okay. So that's why this is much more computational efficient. Is it clear, or you need more explanation? Please go ahead. I don't mind it. If you have any doubt, same doubt maybe other audience. Okay. So ask me. I'm happy to answer it.
Actually, I'm not fully satisfied, but what I am saying here, ultimately in A11, B11, we are taking two matrix products ultimately. So if in place of 3, 3, we are getting a large number like 10 to the power 6, what you have taken in that example. So why we are, learning or understanding this tensor when ultimately we have to do the matrix multiplication?
So here this T product. T product is not usually matrix multiplication. This structure of T product, this is based on circulant. If you see, so this A1, A2,
Block
A2,
matrix
A1. So this
circulant.
is a block circulant matrix. So this is one properties of block circulant matrix that is converted to a block diagonal because of the time restriction and
Via
within,
fast Fourier transform.
yeah. So then we can write A into B instead of we can write FFT of this two block. So that way it is easy or like a fast computation. However, in the tensor computation required more time. So this is one thing. Another thing is if you convert always, okay, so the tensor you convert a matrix and do something. Let's say you add some one row or one column or something, and then you do. So that means each time you need one fresh multiplication. However, this is not true in this case.
Yes, sir.
So like a color image I told you. So color image that is, let's say, AX equal to B. So you are talking about simple things. Application point of view thing. AX equal to B. How will do? A inverse into B. So A inverse means this inverse invertibility conditions required and then multiplication. Okay. So this way you can straightforward, you can do it. And other way like singular value decomposition I told you. So that image compression using SVD. Okay.
Okay, sir. Thank you.
Anything else?
Hello, sir.
Yeah, hi.
I'm Dr. Vikas. So,
Yeah.
can you refer some books which will help us to read more on tensors?
So right now there is no proper book for the tensor representation or other things. Maybe you find out one or two books that is We. So I'll share with you here maybe, or if you go to my website, so it is available. Okay. So two books I refer it basically. So they are discussing not only the Einstein product and the T product. There are other product also. You can go over it.
Okay, thank you, sir.
There's somebody that's standing now discussing. Madam Karitha.
Anything else?
Audience, any queries?
Sir, are you sharing your PPT things for the participants, sir?
If you'll say, then I can share.
Yeah.
Okay, I'll share with you.
Suppose you share it with me, we are going to share it with through mail, sir, everyone.
Yeah, some part of this slides also not published. So,
okay, sir. Apart from that, you please send it by today or tomorrow, sir. What are things published? You please that much. Means basic sense, tensor, why they need use. These are the things you told us much simple.
Yeah, like one of student asked me the question regarding the books. So let me share with you one book. So
yes, sir.
This is one book. Is it visible?
Yes, sir. Visible, sir.
So this is one book. Let me at the bigger screen. So tensors for data processing. Okay. So this book, they can refer it. Okay. So tensor decomposition and computations and tensor singular value decomposition, multidimensional image, all these things is there. So please note down this book. Okay. This is this one. Tensors for data processing, theory, method, and applications. This is the 2022 books. And another book is there, like a tensor computation for data analysis. Is it visible?
Yes, sir.
Yes.
Please write down. Those are interested to work on this. So basically, this is just 1 year before. All books are recently. So you don't think that this is very traditional things. So all books are here. They discuss tensor computation, tensor decomposition, low rank recover, tensor for deep learning. Learning. Okay, many things they discuss it here. Tensor decomposition in deep network in tensor approximation. Okay.
Sir,
So,
please show the first page, sir. 1 second, if you don't mind.
Yeah.
Thank you, sir.
Okay, I can say that these two books, if they will go over it, so
Yeah.
these two books are a recent book, and
Okay.
no other book is available right now, as per my understanding. So
Okay.
those are interested to do some research, they can follow it and do it. Right now, this is very like a surface level of work is going on in this tensor computation. So those are interested really, they can do some kind of work. Dr. Vikas, you can
Yes.
see these two books and
Yes. Thank you.
I'm going to teach also this semester this tensor computation for data science in here. So this is first time in India. You can say that tensor computation theoretical and applications are quoted in this IIC.
So, as a skill development dean and a student welfare officer, I'm asking one request for my side, sir. Any our computer science or information science students, they have an interest to do any small project like that. You are ready to allow for the students, sir?
So you know that I am agree, but students should show their interest.
Yeah,
If you are saying on behalf of the student, so then
yes.
I cannot say that this is good.
Yeah. Understood, sir.
Like they should show interest that I am interested in specific applications and specific like theoretical part. Because as for my research, I do both theoretical part of and application point of view, along with neural network also. Okay. So if you go to my website, so they can see students should feel interest at which direction they are interested. Because if they are in mathematics background, they may not have well trained in neural networks. They can go for theoretical work. Those are in computer science, they can go for the neural network and application point of view. And most of my work is also image processing. So in those are in electrical and computer science, they can come for internship and other things. So right now, 1-2 internship student they are doing. But let me say that one fact. So some student they are requesting that okay, I like to do internship. So when I replied that okay, so which topic you like to do? Can you write a paragraph? They're stop writing. They're saying that okay, they're not replying anymore.
Oh, okay, sir.
So that means they are not interested. Are you getting my point? So
Yes, sir.
which area they are interested, either theoretical or applications or neural network. So which direction they should write one paragraph that why I'm interested. I'm not saying that 5 page, 10 page you write it. So that paragraph they are not interested. They interested to come here and go. So that
Yes,
I
sir.
don't like it.
Okay, sir.
So if really some student showing their interest, they can come. I'm happy
Yeah.
to consider.
Yes, sir. Suppose some students are they are very good students. They're going to ready to write what they're going to write, doing that in paragraph everything. They really showing the interest. I'm going to give a mail ID, sir. Suppose you are comfortable with the students. I'm requesting you my side, if it's possible.
So this is they can go over my web page. So this is
yes,
my lab. Okay.
Yeah.
So they can read that about my research, what I'm doing. So this what is
Yes.
the tensor and also image things, and then also I worked on wavelet applications. Okay. So
Yes,
that
sir.
also I mentioned, and some of open problem. Those are interested, they can go over it. Okay. Still now,
Yes, sir.
like this is still now it is open. I can say that. So
Yes,
if
sir.
somebody interested, I can design an adaptive space-time curvelet and its applications. They can do it. And the tensor operations and its application, machine learning and deep learning, they can do it.
Yes, sir.
So and they can go over these publications. If you see, so go over their publications. So recently, this is 22 neurocomputing. So that is a neural network with simple matrix equation. Okay. So they should go over it, they should read something, then write. Instead of writing, my suggestion to all students, you should take initiative what you will do. Instead of I am forcing you, please do it. So then you may not feel interest. Are you getting my point?
Yes, sir.
So in that point of view, all of students, those are here in the sense this seminar attending. So I can say if any paper or any work they feel interest, they can write that email that I am feeling interest in this specific paper. So is there any possible way I can extend this work? So then I can suggest immediately, okay, as you completed this one, so I can give you this work that we can do it.
Okay.
Okay.
Okay, sir.
Okay, thank you.
Thank you very much, sir. You are giving very nice talk. Maya is going to wind up this session.
I'll conclude, ma'am.
Yeah.
Thank you very much, sir, for your insightful thoughts about the TensorFlow. So the students might have understand, sorry, not students, all the participants of this webinar have understood how they can use the TensorFlow in the recognition of the number plates, even if it is fast moving and the image clarity is not there, how this TensorFlow will be useful. So from then, with the various aspects where and all the TensorFlow can be useful in the processing, including the image compression, and they got an idea what are the textbooks available, what is the present research going on. Even if they are willing up to take up their research, they can think over it. Thank you very much, sir, for your wonderful presentation.
Okay, thank you. Thank you very much. Bye-bye. Have a nice day.
Thank you, sir. Thank you.
Okay, so I'm leaving. I have some meeting. So
okay, sir.
Please continue.
Yeah.
Okay.
Thank you
Okay,
once
bye.
again, sir.
Thank you. Thank you very
Bye,
much.
sir. Take care, sir.
Thank you, sir.
Okay. Nandan, sir. Nandan, sir.
Yes, ma'am.
Are you
Good morning, ma'am.
now, sir? Yeah, good morning, sir.
Good
Yeah,
morning.
sir, we are going to start now, sir.
Yeah, no. Of course.
Yeah. Dr. Gunavati?
Yes, ma'am. I'll just make sure as a presenter.
Yeah.
Yes, ma'am, I've done.
Yeah.
So can you please just check it once? Is it shareable?
So, ma'am, it is visible to you?
Yes,
Yes,
sir,
sir.
it is visible, sir. Sir, I just give a brief introduction about you, and then I'll hand over the session to you, sir.
Okay.
So firstly, I welcome you for this 3-day webinar on National Mathematics Day. Sir, Dr. Sharada Nandan Rao, Associate Professor, Department of Mathematics, National Institute of Technology, Raipur. So area of interest is mathematical modeling, mathematical ecology, and many more. Sorry for not mentioning all because it is having a lot of areas of interest. So I just want
So not
audience to
recording.
have a look in so that you'll get to know. You can seek the help with a lot many topics there. So, Sir has published 40 publications in the reputed journals and 9 in the national and international conferences. Sir has conducted many some courses, short-term courses, workshops, and conferences. And the very important points about the things here is the sponsored projects. The details of the sponsored projects are like the time delay and disease effects on the dynamics and stability of the ecological system, mathematical modeling, controlling, prediction, application and management, sanctioned by SERB DST of amount rupees 6,60,000. The second sponsored project is mathematical modeling of ecological systems and application to the biological science, sanctioned by SERB DST of amount rupees 20 lakhs 28,565. So we're very happy, sir. So at least you can just add on that how the people can look into these projects as well. So under Sir guidance, so the 5 students have completed their PhD, and altogether there were 6 scholars. So Sir have experience with various disciplines, what I can say, like designations as a research fellow, senior assistant professor, associate professor. So have various types of experiences, what I can say, in this work field. Sir have a membership of national and international professional bodies, of lifetime membership of International Association of Engineers, Hong Kong, lifetime membership of Indian Mathematical Society, India, lifetime membership of Indian Science Congress Association, India. The awards and achievements: the Best Mathematical Modeling Team Award for the Mathematical Modeling Project of the Industrial Problem in DAAD. German Academic Exchange Service support international workshop on computational PDE modeling and simulation, held on January 3rd to 12th, 2011, conducted by the Department of Mathematics, Indian Institute of Technology, Madras. This is the German. So there are, Sir has become a reviewer for various reputed journals. So Sir has visited multiple countries, Italy, Greece, Hong Kong, and so. With this brief introduction, I request Sir to take over the sessions.
Thank you, ma'am, for a big amount of ideas about me. So thank you very much. So just can I start the session?
Yes, sir.
Okay. It is visible to you?
Yes, sir.
Okay. So first of all, good morning to all. Myself, Sardananda Rao. The topic of presentation is fundamental of mathematical modeling in science and engineering. So before going to this, just I'm giving some why with the mathematical modeling is required now present day. So as you know that world around us is full of phenomena that seems regular, random in both space and time. The world experiencing catastrophic global environment problem such as climate change, global warming, rise in sea level, the rapid urbanization, globalization, and industrialization have this pace of changes and have expected several ecological stress on the earth and life supporting system at all scale, local, regional, and global. Due to this, our ecological environment become a huge and highly complex system. This complexity arises in part from the every individual biological species, but also from the complexity of every individual organism. So knowledge for the mathematical modeling of this complex system becoming a core concept and improving of our life and future. So the recognizing the correlation of human, their culture, there is a need of dynamic analysis, modeling analytical tool is undeniable. So the knowledge for the mathematical modeling is one of the tool we must use in our effort to make a world our better place. So see the first line that is written in the green line, that is regulate of mathematics, work engineering to all knowledge, since who is ignorant of it can not know the other science or the things of the world. This is the Roger Bacon is the English philosopher that that person know the importance of mathematics. If you don't they know the mathematics, that is the injury for all knowledge. This is the injury for all this branch of science. That is, so we must know the mathematics and its application to express the real world problems. So okay, so see, imagine this. One day we come out from our house and all we see is a big puffs of black smoke and no all we see the car and no birds. As we see is a gasoline and no clouds. What kind of life is that? So imagine this, only the black smoke, no birds, no flower. So what kind of life is that? So that is the reason. So becoming a global warming. See, the effect of global warming, melting iceberg in iceberg alley in the Newfoundland in Canada. Then this is the effect of global warming and the climate change. You can see the effect of the tsunami. How many person are died out in this tsunami? So rise in sea level, conservation of ecology, and these are the factors which affect our environments. So before I am giving this some basic examples, though, then we'll start the mathematical modelings. What is the factor to influence our environments? So first one is industrialization. Due to industrialization, so uh, polluted air affect our environment day by day, and then we can see from this figure this chimneys eject this polluted air. That's why the large amount of waste generated by industry leads to pollution of resource like air, water, and land. And then urbanization. Urbanization is a controversial issue with both pros and cons. Some say urbanization is a good thing because it benefits the economic and strengthens the industrialized world. Others say that it is a major threat to environment because the pollution that the cities emit. Urbanization can also lead to overpollution and lack of space. See in the figures, overpopulation, number of vehicles increases day by day, and the largest or tallest flats and the buildings will nowadays uh, going on, and that's why a lot of the space is covering due to this largest number of vehicles, population, and like those, and then deforestation. So deforestation is one of the main problem of global warming. It is because the air that we breathe constantly that the O2 originated from the plants and trees. It is very difficult for a scientist to figure out that if the oxygen supply will seriously compromise, then the CO2 level will rise dramatically, which will enhance the greenhouse effect that cause the global warming. Due to the deforestation, the wild animals comes on the road and attack on the human. It's just one example of the bad impact of deforestation. So, what is the actually before going to the modeling, first we should know the what is the problem, what is the real world problems. So here I'm some collecting the some points that represent the real world problem. Estimate the world population in 2022. So how we can estimate the in 2020 the population of the India or population of the world is going on, and controlling of coronavirus in hand or what. So nowadays this coronavirus is going on, is going on, this disease is going on. So we are some as a mathematician, some people work on this study of the coronavirus with the help of the mathematics. And the third problem is find the concentration level of the pollutant in the Ganga river due to discharge of waste, and certain disease like hemophilia, bleeding does not stop due to inadequate clotting agent are genetically transmitted only by the female. Predicting the spread of this disease in successive generation, given the fraction of males and the females suffering from it at a particular point in time. So these are the some problems. Reducing the cost in the large hospital is to optimize the allocation of resources, beds, doctor, nurse, to, to types the activity, orthopedics, intensive care unit, surgery, etc. They help the hospital administration to reduce the cost of operating hospital. These are the problems where we can do the mathematical modeling. So another example is a doctor administration and intravenous injection of an allergy, fighting medicine to a patient suffering from the allergic reaction. The injected take a total time t. The blood in the vein flows with mean velocity u, such that blood over a region of length L is equal to ut contains the injected chemical. The concentration of the chemical in the blood is C naught. What is the distribution of chemical in the vein? It is reached the heart 75 seconds later. This is the problem where you can do the mathematical modeling. So one of the field is differential equation. That is very important, and it is a heart of analysis to study the real world problems. So what is the application of mathematical modeling? Actually it is applicable everywhere, such as study of the physical problems, study the environmental problem, study the industrial problem, study the biological problem, to study the economics and other social sciences and nonlinear dynamics related to real world problems. So I'm just giving some examples where we can do the mathematical modeling, then I will start the main topics of the mathematical modeling. So organization of the talk is like this: basic concept of mathematical modeling and basic concept of modeling in ecological system and biological system. I'm not going to this part, just I'm focusing on these parts. Basic concept of mathematical modeling. So first one, what is the mathematical model? Mathematical modeling is a discipline which helps us shaping the real world problems into the mathematical model and solving them. So I have shown the previous slide. There are a lot of the field where the mathematical modeling we can do. So first we are point out the some problems, then we convert that problem in the with the help of mathematics. So this is the basic concept. Mathematical modeling is discipline which helps in shaping the real world problems. And then say, so how the mathematical modelings, what is the need of mathematical modelings, what is the concept of mathematical modeling, what is the perception of mathematical modeling. With this example we can realize. See, basic concept of the mathematical modeling. See, what is this tree? The trees is mango trees. Okay, this one is the mango trees. So there are two persons. One is businessman and another one is biologist. What they think about the mango trees? what they think about the mango tree. Businessmen, what they think about this one. Think about this. Anybody have some ideas? Think about what they think about this mango trees. Businessmen think about the mango trees. Just wait, it's hanging. Okay. Businessmen think about this is the wealth, orchard and timber. This is the wealth, and the what the biologists think. They think about a living thing, a large plant, nutrient foods. So the object is same, but the businessman thinks about the different way and the biologist think about the different ways. That is same thing happen in the mathematical modeling. What is our requirement? What we want to do with the help of the real world problems. So see, conceptual view of the same object are different. So object is same, but the view is different. The same thing is true with the mathematical models. So what is our perception? What we want to do? That is the important thing in the mathematical modeling. According to that, we have put some assumption. We have to take some natural law. We have to take some mathematical concept. So see some techniques of showing the function by the practical example. This example I have collected from some WhatsApp group. Suppose you want to show the with the help of the pictures to show the function and their inverse in front of the students. So fx is just represented as century. Half portion of this whole body is the horse and the head of the horse is a man. So this is the centure. The f of x represent like this only. Then f inverse x. So reverse of the centure, so head is horse and other parts of the body is a man. So this is only the representation of fx and f inverse x. We can show with the help of this and see fx and gx. So bread is represented as fx and omelette is represented as gx. So f of gx means the omelette inside the bread, and then g of fx means bread inside the omelette. See another example. Fx represent the pizza and gx represent the pineapple. So f of fx equal to f of g of x represent as the pineapple inside the pizza, and g of fx is pineapple inside the sorry, pizza inside the pineapple. So composition of functions. See, black cat and white cat represent as the black and white cat. So we can, with the help of some example, we can show the composition of some functions and see yoga. Yoga se ho. So see, we can see here. So every moment of our hand can represent some function, some curves. So yx, you can see the representation of a curve, and y is equal to x square, y is equal to x cube, y is equal to sin x, y is equal to cos. Like this one, every moment of our hand shows some curves. So this is the life. I have collected some this snapshot from the WhatsApp group. So life is a integration of happiness upon time with respect to t. So from day birth to death. So I am giving some problems within which to take the 2 minutes and just solve it. What is your perception? Just I want to check it. Suppose there are 9 points in given such a patterns. Question is what we have 4 straight line. Sorry, question is that we have 4 straight lines to join this point in such a way that no two straight line intersect at a point. Just take 2 minutes. I will show the answer. So this is the question. You have only 4 straight lines, and to join this point in such a way that no two straight line intersect at a point. So at a point, no two straight line intersect. So do it. After 2 minutes, I will show the answer. Okay, just do it. I'm waiting for 2 minutes. Then I will show the answer of this one. Just I want to check your perception, how we can solve this, because different person has a different idea to solve this one. It depends on this person. So before wasting the time, just I'm showing the answer of this one. See, the answer of this problem is like this only. So it is rotation, not intersection point. Okay. So this is just see the like that one. So this is the, so you have to go beyond the think. So you somebody think about this only here. So you have to go beyond the these things. So you have to some another system to solve that problems. So see message, only after the last tree has been cut down, the last river has been poisonous, the last fish caught, only then we will find that one money cannot be done. So we have to focus only the, we have to focus on the greenery. So you have to make a tree plantation and a time of intervals and the save the our earth at like a greenery. So this is the not ending of the my presentation. It is just a beginning of the my presentation. So I'm showing the main topics. Just wait. So basic concept of mathematical modeling, that is the, we have to focus on the principle of the mathematical modeling. See, why modeling? So I already explained these things. The fundamental and quantitative way to understand and analyze the complex system and phenomena. So these are the some basic things. That's why we are doing the mathematical modelings. So fundamental and quantitative way to understand and analyze the complex system and phenomena. The experiment to theory and experiments and the complement to theory and experiment and often integrate and becoming widespread in computational physics, chemistry, mechanics, material biologies, and in all branch of engineering. So mathematical modeling is going on. So what are the goal of the modeling study? Appreciation of broad use of modeling, hands-on experience with simulation techniques, develop communication skill working with practicing professional. Sorry, just resume, just wait. Okay. So mathematical modeling. So mathematical modeling seeks to gain an understanding of science through the use of mathematical model on computers. So before going to doing the mathematical modeling, these three components work together, then we become a good mathematical model. Computer science, mathematics, and science. So computer science means you should know the some numerical techniques, some computer programmings, and if you are expert in the mathematics, then you can do the mathematical modeling. Then science means you should know the natural law. Okay, so you should, suppose I am dropping a pen. Suppose I am dropping a pen, so it's come on the surface, fall down in the surface, not go away from the surface. So this is the natural law, Newton law of falling. So you should know the some natural law of motion. You should know the some natural law. So this is the science. And computer science means you should know the some programmings and uh, simulation work. And mathematics, you should know the basic concept about the mathematics. So all these three together work, teamwork are required to doing the modelings for the mathematical modelings. So complement but does not replace the theory and experiment in scientific research. Mathematical modeling does not replace the theory and experiment in scientific research. So you should take the experiment and theory, then computation. So both can come in the computation, experiment and theory. It not replace the basic concept about the experiment and the theory. So that means theory means natural laws and experiment means so science. So mathematical modeling is often used in place of experiment when the experiment are too large, too expensive, too dangerous, are too time consuming. When this factor is going on, then we have to do the mathematical modeling. Can it be used? Mathematical modeling can be useful in what if study. Example, to investigate the use of pathogens, virus, bacteria to control an insect population. Nowadays, the coronavirus, for controlling of coronavirus, we are doing on that mathematical modeling on that problems. So mathematical modeling is a modern tool for scientific investigation. So these are the field where the mathematical modeling is going on. I am already explained this one. So some example application of mathematical modeling is spreadness of disease. So nowadays the spreadness is in China, somewhere lockdown is going on. So spread up to controlling the spreading of the coronavirus. So urban city I have explained, highway traffic management, stock market prediction, artificial intelligence, where we can see the mathematical modeling is going on. So some examples: population ecology, Canadian lynx, and otherwise snowshoe rabbit. So it is a one interaction between the population, that is we should know the Lotka-Volterra model. If anybody want to know this, see the Lotka-Volterra models. That is the explanation of the Lotka-Volterra model, Canadian lynx and snowshoe rabbit. So interaction between that two population is shown by the Lotka-Volterra model. This is the time series analysis, time evolution of the snowshoe rabbit and Canadian lynx, how the population is going on. Okay, then tumor growth. Mathematical models have been developed that describe the tumor progression and help predict the response to therapy. In this field, the mathematical modeling is going on, and the electropsychology of this. In the 1950, Hadkin and the Huxley introduced the first model to design the reproduced cell membrane action potential. They won a Nobel Prize for this work and sparked a new field of mathematics that is known as excitable system, where this thing is going on. So microbiology and immunology. So how to immune cell find a bacterial target? Under what condition can the immune system control a localized bacteria infection? It comes in the mathematical biology portion of the mathematical biology, where we are doing the mathematical modeling. If the immune system fails, how will the bacteria spread in the tissues? So next, the biological patterns formation. How did the leopard get this spot? A single mechanism can predict all these Turing's. There was a mathematician, Alan Turing, who has described the patterns of the species, how they are living. So this mathematical modeling is going on these fields. So industry. So before going to the making a plane, so just we use the finite element techniques and formulate the first basic structure of the planes. Then it mock up the full scale. Okay. Then computational modeling improve the quality of work and reduce the change and error and rework. Okay. So first jetliners to be digitally designed, assemble on the computer, animating need for casting and full scale mockup. So see roadmap of the brain, human brain, so how it is work. And here in this field where the mathematical modeling is also going on, neurology, mathematical modeling of neural. Okay, so climate modeling is going on. So basic things of the mathematical modeling, how the mathematical modeling process work. So first, you are taking the real world. We are taking the real world problem, then simplify it. Then we make simplify. Then we make some assumption. Then we represent the working model. So what is this? After simplification, then we make working model. Then represent with the help of its representation with the help of mathematics. Then it's become as a mathematical model. So translate it into the computational model, then simulate it. Use of the computer programming or some simulation techniques. So you study these computational models, then you have to find the result and conclusion. Then you have to interpret it with the help with the real world problems. If it is justified, then you stop this process. Otherwise, you just put some more assumption and remove some assumption, then repeat this process. Then you can do the solve the real world problem with the help of mathematical modeling. See, I will explain the one by one step. So first we are taking the real world. So first we have to identify the problems. So identify the real world problems. So perform background research focus on a workable problem. So first point out a problem, then think what is the literature available at present scenario, present situation. So you just collect the some knowledge regarding to that problems, what is the literature available at the present situation, and conduct investigation if appropriate. If it is required, then you can conduct the investigation or in the lab and learn the use of computational tool, MATLAB, Mathematica, Excel, Java, Python. Nowadays, the Python is going on. So some students are using MATLAB and some students are Python. So you should know the some programming, some techniques, computer techniques by which we can analyze the model. So understand characteristic and predict feature. So first you should recognize the real world problems. Suppose here I am taking the one example. Determine the motion of rock dropped from height h and above the ground with initial velocity v. So a discrete model. So I'm making the discrete model. So a discrete model find the position and the velocity of rock above the ground at the equally spaced time t0, t1, t2 and so on. Example, t0 equal to 0 second, t1 is equal to 1 second, t2 is equal to 2 second and so on it is. So here t0, t1, t2 and tr. So working model. Now we are going to the second step, working model. Now we are making the working model. So what is our aim? Identified and select the factor to describe the important aspects of real world problems. So first we have to identify and select some factor, what factor is working on this model. So just determine that. So determine those factors then can be neglected. So some factor you have to neglect what is not required for the model. So state simplifying assumption, determine governing principle, physical laws. I am already told. You should know the before going to solving the and formulating the any real problem. Just you should know about the what is the physical law is required for that problems. So determine the governing principle, physical law, identified model variables and interrelationships. So you just see what how many variables are required, what is the relation is required, what is the formula is required. You just should know, collect that things. Okay. So falling of rock, Dixie, governing principle is, you know that x is equal to b into t, b star into t. That is means velocity into the time, and velocity equal to acceleration into time. So simplify assumption. Gravity is the only the we are now impose the some assumption. Gravity is only the force acting on the body and flat earth. No drag, air resistance. Model variables are h, b, g, t, x, and v. Rock's position and velocity above the ground will model at a discrete time t0, t1, t2, and so on until the rock hits the ground. So we are just checking at the discrete time intervals up to the when the rock hits the ground. So see the mathematical model, how you can formulate the mathematical model. The next step, mathematical model. They express the working model in the mathematical terms, write down the mathematical equation whose solution describe the working model. In general, the success of mathematical model depends on the how easy it is to use and how accurately it predicts. So you have to make the simple model. First, you to make the simple model related to the real world problems. See, so at T naught, displacement is x naught, velocity is v naught. At T1, displacement is x1 and velocity is v1. Similarly, at T2, displacement is x2 and v2, and so on Tn, x and pn. So at initial condition, we take the initial condition T naught is equal to 0, x naught is equal to s, and v naught is equal to v. So after time, at the time T1, its time is T naught plus delta T. So difference between this is delta T, and T2 is equal to T1 plus delta T. So x1 at T1, the displacement is x1 equal to x naught plus Newton law of motion. See, Newton law is a physical law. Okay, so according to Newton law of motion, so x1 is equal to x naught plus v naught star into delta t, and at x t2, x2 is x1 plus v1 into delta t, and here at t1 the velocity is v1 is equal to v naught minus g star into delta t, and at t2 velocity is v2 is equal to v1 minus g star and delta t. Similarly, we can find the at t1 and t3 and so on. See, now then computational model. So change the mathematical model into a form suitable for computational solution. So for computational solution, we change the mathematical model with the help of some techniques. Sorry. Now first, you should check the existence of unique solution. Its solution exists or not. So you just take the unique solution and choice of the numerical method. So you have to select the appropriate methods, numerical method by which we can solve the computational models. Otherwise, it's get the error. Okay, error in the solution. That's why we have to repeat the whole process again. So choice of the algorithm, and proper choice of the algorithm is required, and then software. It depends on you what software you are using. Okay, so proper choice of the algorithm and numerical techniques give the appropriate the result. Okay, see. So change the mathematical like this. The computation model includes software such as MATLAB, Excel, or Mathematica, or language such as Fortran, C, C++, Java, or Python. So you should know this thing. Nowadays Python is going on, and some person are using MATLAB. So see how you can make the code pseudo. So input B is initial velocity, H represents the initial height, G represents the acceleration due to gravity, delta T time step size, I max maximum number of steps, and output Ti. T values at a time step I, Xi height at time Ti, Vi velocity at time Ti. So initialization, set Ti equal to Ti equal to T naught equal to 0, and Vi is equal to V naught is equal to B, Xi is equal to X naught equal to S. Initial condition. Okay, just take the initialization, just keep the initial condition. Print Ti, Xi, and Vi. Time is stepping I is equal to 1 and I max. Set Ti is equal to Ti plus delta T, and set Xi is equal to Xi plus Bi star into delta T. Set Bi equal to Bi minus G star into delta T. Print Ti, Xi, Vi. If Xi is less than or equal to 0, then set Xi is equal to 0, then quit. Otherwise, it is not whole, then you repeat this process again. Okay, otherwise use some other formula for this. Okay, this is the formula of the Newton law of motion. So see result. Now we come to the portion result and conclusion. See, computational model to obtain the result, draw a conclusion, verify your computer programs, use use check cases, explore range of validity. So what is the result come after simulation, after computer programming? Just see what is the range of validity, is the result is valid or not, and graph, chart, other visualization tool are useful in summarizing the result and drawing the conclusion. So just plot the, it depends on the problems, what is it required. Graph is required, just draw the graph. Chart is required, then use the chart. And the visualization, some time series evolution, phase part trace, patterns, all those things are required. If you require, then you plot that things and just check it is valid or not. Okay, next. So falling off rock, here I am showing the with the help of the some pictures, so some graphs. So this blue line represent the height and red line represent the acceleration, and green line represent the velocity. Here height and downward velocity. So falling off stone, that is one acceleration of gravity is working on that falling on stone. So see, suppose we are taking the velocity at initial state at time t0. So at 0, its velocity is 105. You can kilometer per hours or meter per hours, you can take, it depends on you. So acceleration minus 10. So acceleration is everywhere, acceleration is same. So gravitational force is working, and that is minus 10 everywhere. So at 0, so velocity is 105, and acceleration is minus 10, and the displacement is 20. Sorry, displacement is height is 65. Then its velocity is minus 20, and the then at this height is minus 40. Minus 40, then its velocity is 25 kilometer per hour or meter per hour. So we can see the how this is falling. To be with the help of this picture, we can show that falling of rock. Okay, so this is the representation of the rock model, falling of rock model. So how it works when we just drop down the stone and it's come up to hit this surface. So this is the picture that show the dynamics of the rock. Okay, so see interpretation. Now the next step is interpretation, that is conclusion. Compare with the real world problems behavior. So how we can check if the model result do not agree with physical reality or experimental data. So re-examine the working model. So we just check the what is the assumption we have taken for formulating the real world problems. So if some assumption as we have to relax, or some assumption we have to incorporate. Okay, so see here, examine the working model, relax the assumption, or repeat the modeling step. Yes, if it is required, you just impose some assumption and then repeat the modeling step, and happen the modeling process, proceed through the several iteration until model is acceptable. Up to acceptable level, you just repeat the model process. Okay, so some put some assumption, if it is required, some remove the assumption, then repeat all whole process, then you can find the a valid model. Okay, see falling up rock. So to create a more realistic model of a falling of rock, some of these simplifying assumption would be dropped. Example, incorporated drag depends on the shape of the rock, so is proportional to the velocity. So sub resistance is working. Suppose we are incorporating the resistance of the air, so it's work on that. So improve the discrete model. So as approximate velocity in the midpoint of the time interval instead of the beginning. So at the beginning, we can take some assumption we have to incorporate to for modeling the discrete model for the falling of the rock. reduce the size of the delta. So then we repeat the whole process. Again, we repeat the whole process for the after imposing some assumption and some natural law. So we repeat this process till we obtain the required models. Okay. So this is the some references, some basic books by which we can know the how we can do the mathematical modelings. First book is mathematical modelings, that is Mark M. Richards, Academic Press, and next book is mathematical modeling and computer simulation. Okay, D.P. Maki and M. Thompson, and introduce the mathematical modeling by Edward A. Vanderdover publication. These books are basic books by which we can know the some important aspect and some important factor of the mathematical modelings. Now, thank you. So, ma'am, my side is over.
Yeah. Anybody? Gunavati?
Yes, ma'am. Any queries from the audience? Sir, actually, I myself have one small thing. You have gone through the steps how we can do the modeling. Is it possible, like with any simple example, how the model look like with this process?
So, ma'am, we have given this one example as a falling of wrap. So each step by each step we can go the for formulating the real world problems.
Okay.
Okay, so you just take the collect the some problem. If you want to doing the mathematical modeling, you just go through the real world problems, and then think about the what is the aspect we have to improve here, and then we have to collect some literature review. Okay, so what is the literature review available at related to that problems? Just see what is the mathematical modeling is going on at the present situation. Okay, what is the aspect, what is the factor we have to incorporate to formulate that real world problems. So step by step we are going, then we can definitely we comes at the at the at the level of accuracy. Level of accuracy means that you can obtain a good models that gives the represent the real world problems what we have taken the in earlier stage.
Thank you, sir. Any queries from the audience side?
One more thing, I would like to thank your slide, whatever you put it, life is equal to integral of birth and death of happiness with the time. It's very impressive, sir, that slide.
Thank you, ma'am.
With the mathematics in our life, you are involving that, putting into integrated, you get a happiness in that one. I thank you for that slide, sir. I very happy for that to see that slides.
Thank you, ma'am. Any other query?
So somebody posted in the chat group.
Just I am unable to
What
see.
is the
Just I want to
use?
see that query.
No,
I'm
no.
unable to see.
I'm just reading. I'm reading, sir.
Okay.
What is the use they're asking? Oh, sorry. One more query is there, sir. So actually, the query is like, why formulating modeling? We make some assumptions to make our solving easier, but actually it is not the case. What is the use? This is what they're asking.
They are asking about the why we are using this system.
Yes, sir. Why we are making the assumption to make our solving easier?
Because
actually, that is
suppose I'm
not the
giving
one.
you the help of the one example. Suppose I'm dropping out this one. Suppose Newtons are sleeping in the was sleeping in the apple tree, and I know this is a natural law. This is no everything is come on the surface. So suddenly the apples drop down in the on the surface and on his head. Then think that, oh, why this thing happens? So then they impose, if you are dropping some things, it come on the surface. So there is a need of some natural law. That means you can't leave that natural law, because without imposing these natural laws, then no model is real. Okay, suppose I'm eating something, so it's come in the another form of development of my bodies. And suppose a species is taking some food from the other species, there is some growth in the other species, and this is the natural. Otherwise the model is not realistic. Suppose something is uh, um destroy in another farm, then that thing is developed in another farm. This is the natural law. So we can't accept the natural law. We have to take the natural law in our assumption. So suppose this is the natural law, we have to impose this assumption. Then we are able to develop the real world models. Otherwise, it is incorrect. So we have to take the some assumption, that is basic assumption. Ma'am, I think hope you are
I
getting.
think they understood, I hope. If the answer is satisfied, please do reply. You can
Vidya
unmute
madam?
yourself and you can speak, madam.
Vidya madam, please.
Sorry, sir. Hello.
Okay.
Am I
Tell me.
audible?
Audible, ma'am?
Yes, sir. My question is, for make our solving easier, we are, even though some laws are there, we are
Okay.
neglecting that, and we make our modeling easier.
Okay.
Actually, it is not the case now, sir. So how far we are giving the weightage for that? So we are not solving actual situation. Then how far our modeling will be correct then?
So modeling is give the some prediction, ma'am. It is a theory, is represent the theoretical aspect of the that situation, and based upon that we can uh, find the result of that situation. What is going on after sometimes it give the some forecasting of that situation, not exact situation. Okay,
Yeah.
if you are doing some mathematical modelings of the situation, because that is the development of the mathematical is going on. Otherwise, suppose anybody gives some mathematical modeling to relate to that problems, so that model is not the last model. There is a scope of improvement of that models. We have to impose some assumption, and then after that we can develop the another model to relate to that topic that represent the more accurate, not exact answer. Okay, more accurate.
Yeah,
Okay.
because we are neglecting something, no, sir. Actually, it is presence there, but we are neglecting certain laws.
I'm neglecting that. We are neglecting that assumption which is not related to the that problem. Initially, we are taking. Okay.
Yeah.
The after analysis, we can realize that this thing is not required for that situation.
Okay.
That is the main issue.
Okay, sir. Thank you.
Okay. Anybody? Sir, I'm just trying to check the chat. I am unable to see where is going on. Actually,
That's
I have
fine,
taken.
sir. I'll check it for that.
Okay.
Any queries from the audience? You can unmute yourself and speak, or else you can put it in the chat box as well.
Any query, ma'am? More query?
No queries, sir.
So
Yeah, one small announcement for the audience. The feedback link is being shared in the chat box. Please do fill the feedback. Sir, I'll just conclude the session, sir. So thank you very much, sir, for your
Thank you, ma'am.
talk
Thank
on
you
this
for inviting me.
mathematical modeling. So you have covered all the aspects which comes under this, from the fundamental requirements of modeling, what are the goals of the modeling, and the various fields we can cover up in the modeling, and with a natural example like how we can go stepwise, so that they can make use it for their research topic, the steps what they need to follow, and how they can able to prepare the mathematical model. Thank you very much, sir, for your informative session.
Thank you, ma'am. Can we leave now?
Participate
Can we
asking
get PPT,
Can
ma'am?
you provide PPT, sir?
Yeah, I will share you on the mail, ma'am.
Yeah, Rupa madam, you can share, sir. We can,
Yeah.
we can get it. Sir.
Thank you, sir.
Thank you,
Thank you,
sir.
Nandan, sir. We are accepting our invitation. You have given a very good.
Thank you, ma'am, for inviting me. Thank you, ma'am.
Yeah.
So can I leave now?
Yes, sir.
Yeah.
Okay.
Yes.
Okay. Thank you, ma'am.
Dear participants, link will only be available in the chat box. Please do fill the feedback.
And also announce tomorrow's session, what time we are going to
Yes, ma'am.
do the. Don't do that.
So tomorrow's is a presentation from the students. The session starts at 2 o'clock.
It's a
Please
blended
do
mode.
be join at 1:55. The link will be shared in the WhatsApp group. So it's a PPT competition from the first semester students regarding the mathematical applications in engineering.
Somebody they're telling Gunavati
Form is not, yes, ma'am, it is opening. Please do check it.
Maybe sometimes, madam, sir, your network is not good. Maybe happen like that.
Because I already received 26 responses. Please do check it. Okay.
Yeah, Gunavati, you told no blended mode like that. We are doing that online only, that PPT presentation competitions.
Yes, ma'am.
Yeah.
PPT presentation competition is in blended mode, so the students will be offline and the audience can able to listen. If any of the BIT, they can attend in the room number 523. It will be organized there if they want to attend an offline session. Form will be open for another hour. So if anybody wants to take up the link, you can take it from the chat box. This will be closed in another half an hour. The WebEx link. Thank you all for your participation for today's session. We look forward the same thing for the tomorrow's and the day after tomorrow's. It's an offline, so we share the video of that.
Day after tomorrow.